All right, today, continuing in Chapter 7, we're going to talk about ratio, proportion, and similarity. Yesterday we talked about ratios and how we could reduce those down. Today we're going to talk about proportions. Yesterday we defined proportion. Yesterday we said that a proportion is when a ratio is equal to a ratio, or a fraction is equal to a fraction. Typically when we write proportions, we write them in their fraction. It just tends to be a little bit easier to see. So in these properties here, these properties are all true properties. We're given a starting proportion of A to B is equal to C to D. These properties show us ways that we can rearrange a proportion and have it remain true. AD equals BC. On the diagonals or cross multiply, AD will equal BC. This is quickly. Okay, so when we're of a proportion, this is going to be our go-to, is to cross multiply. The second proportion says A over C equals B over D. What's going on there compared to the original? How could we get this second property out of the original? How could I find A over C equals B over D compared to the original? Where are A and C? On the tops, okay. Where are B and D? On the bottoms. So what we're doing in this property is we're reading the proportion across sideways instead of reading it across up and down. So instead of saying A over B and C over D, we're reading it across A over C, B over D. Read it across. The third proportion, B over A is equal to D over C. What change was made there from the original? They're both upside down. And that's okay to do as long as you do to both of them. You can't just flip one of them upside down. But as long as we flip both of them upside down, it'll still all work out. The next one says that we add together, or we could subtract, the tops and bottoms of one side, keep it over the same bottom, and then do the same thing on the other side. This one leave or just see. So I'm going to throw some numbers out. And let's say our original proportion was 2 over 4 is equal to 3 over 6. For starters, is that a true proportion? Yes. Why? They both equal 1/2. Okay, so 1/2 equals 1/2. So this fourth one down then says that we can add or subtract the tops and the bottoms. So that would be 2 plus 4 and keep it over the same bottom. And do the same thing on the other side. And then we need to say, is this still true? Well, that gives me, is that true? Does 6 over 4 equal 9 over 6? What do they both reduce to? 3 over 2. They both reduce to 3 over 2, so that must be a true proportion then. So this property says that we could add or subtract top and bottom, keep it over the same bottom, as long as we do it on both sides. And it'll still remain true. The final one says that if we have several ratios all set equal to each other, so not just two ratios set equal, but several, A over B equals C over D equals E over F, and so on and so on and so on, as many as we want. If we take put it over all, it'll equal the original proportion. Any part of that original portion. So we could say it equals A over B, we could say it equals C over D, it equals E over F, because those were all equal to each other in the first place. So we're going to apply these properties today. So using the original proportion, x, what would 5y be equal to? 2x. This is our cross multiplying property that we multiply on one diagonal is equal to multiplying on the other diagonal. And that's the property that we will use to solve. For part B, what is x plus y over y equal to? 5 plus 2 over 2 or 7 over 2. Whatever you're doing on one side, do the same thing on the other side. So add together top and bottom, keep it over bottom. What does 2 over 5 equal? Y over x. Flip over one, flip over the other. What does x over 5 equal? Y over 2. X over 5 is reading the tops across from left to right. So then read the bottoms across from left to right. Okay. Questions? Okay, I have some more examples for you to work on then. Each of these blanks need to be filled in. The first proportion is our true statement, our starting statement. So like in the first one, a over b equals 2 over 3. That's our starting statement. Then fill in the blank. What would 3a be equal to? Don't say it. Think about it. For all of them, go on through and think about how we would fill in those blanks with true statements. So I'll give you a few minutes to work your way through these, and then we'll discuss them. All right, let's talk about these. For the first one, what does 3a equal? 2b, where did that come from?
Because you're multiplying the cross.
That's our cross multiplying. Multiply a diagonal equals multiply the other diagonal. So 3 times a equals 2 times b. Second one I'm reading down. So what does d over c equal? 7 over 4. What change was made there? We flipped. One side, flip the other side as well. What does e over 5 equal?
F over 9.
F over. What are we doing there? Reading it sideways. Yep.
Oh, yeah.
And then the next one, which is j over g equal? 8 over h. What are we doing there? Yeah, we're reading it across sideways again, but this time we were reading it backwards, kind of from right to left instead of left to right. But that's going up to the top now. What does k plus m over m equal? 2 plus 3 over 3, or 5 over 3. The next one, this is our triplicate proportion here, where we got 3 ratios equal. N over p equals q over r equals 7 over 9. And then we took them all and added up the tops, added up the bottoms. What does that equal? N over p or q over r or 7 over 9. Any of the originals are okay answers there. Okay, that property says that when we add together all the tops and add together all the bottoms, it is equivalent to any of the originals. Writing room for the next one. So go ahead. What's 5x equal? Cross multiplying. So then if this would I solve and get just x? Divide by 5 and I get 8. Just multiply and then divide out to get the variable alone. So that's what we're doing in this last question. If I want to get y alone, I'll begin by cross multiplying, which gives me 7y equals 36. And then to get y alone, divide by 7. 36 does not divide nicely by 7, so my answer is just 36 over 7. No decimals, please. And you don't need to change it into a mixed number or anything, but reduce if possible. Leave them as fractions. Fractions are good answers. Portion. We cross multiply and then divide out to get the variable alone. Cross multiplying is a very cool thing. It works really well to solve proportions.